All right, let's do some more with trig. So Taylor polynomial for this function, degree 3, and with a equal pi over 2. So let's start by doing our derivatives. So there's my first function. My derivative will be 3 cosine of 3x. Second derivative will be negative 3 squared sine of 3x. And third derivative, that's where I get to stop, will be negative 3 cubed cosine of 3x. Okay, so now I'm plugging in pi over 2. So sine of 3 pi over 2, that gives me negative 1. F prime of pi over 2, cosine of 3 pi over 2, that gives me 0. Second derivative at pi over 2. So sine of 3 pi over 2, that'll give me a negative 1, and then multiplied by this negative 3 squared, so that'll give me a positive 3 squared. And then third derivative at pi over 2 will be 0. Okay, I don't need to establish the pattern, remember. I just need to get to plug in the information. So I get negative 1. The next term is 0, so I'm going to go right to this term here. So I'll have plus 3 squared x minus pi over 2 squared over 2 factorial. The next term is 0. So there's just 2 terms for this polynomial of degree 3 because the information gives us 0 from the derivatives. That's fine. It's not the number of terms. Degree 3 means go up to that third derivative. So let's do this one, a little harder of a derivative, right? So let's rewrite this like this before I start taking the derivative. So I bring the negative 1 down, carry the inside along to the negative 2 power, and then I'm going to multiply by the derivative of the inside. So remember, get rid of the 2 negatives, make it positive. Now go take the second derivative. So I get negative 2, 1 minus x to the negative 3 times another negative 1. So 2, 1 minus x to the negative 3. How many derivatives do I need to go to? 4. So here's my third derivative. So I get a negative 3 times a 2, 1 minus x to the negative 4 times another negative. So you can see it's always turning positive. So one more derivative here. So I get a negative 4, 3, 2 times a 1 minus x to the negative 5 times negative 1. So that's 4 times 3 times 2. All right. So now it's a Maclaurin polynomial, so I'm plugging in 0. So I get 1. F prime of 0 gives me another 1. F double prime of 0 gives me 2. Third derivative at 0 gives me 3 times 2. And fourth derivative at 0 gives me 4 times 3 times 2. All right, so let's put this together. First term is 1 plus 1 times x over 1 factorial plus 2x squared over 2 factorial plus 3 times 2x cubed over 3 factorial, and then 4 times 3 times 2 x to the 4th over 4 factorial. And then kind of looking at that, well, I can see that that cancels, so we just get, right, simplified. All right, one more, just uglier derivatives and Taylor polynomial degree 3. So let's start with our function, cosine of x over 2. One derivative will give me a negative sine of x over 2 times a 1/2. Second derivative, carry along the negative 1/2. Take the derivative of sine and get cosine of x over 2 times another negative 1/2. So I'll get negative 1/4 cosine of x over 2. One more derivative. So carry along the negative 1/4, take another derivative, so I'll get negative sine of x over 2 times a 1/2. So I'll get a positive 1/8 sine of x over 2. So remember, I'm plugging in pi over 2. Putting in pi over 2, that's going to give me cosine of pi over 4. So that's root 2 over 2. So the first derivative at pi over 2, I'm going to have the number 1/2, I'm sorry, the negative 1/2, and then I'll have sine of pi over 2, and that's going to be root 2 over 2. Second derivative at pi over 2, I'll get a negative 1/4 times the cosine of pi over 4, which is root 2 over 2. And third derivative at pi over 2 will give me a positive 1/8 times root 2 over 2. So some uglier numbers here, but we're good with that. Here we go. So I get root 2 over 2 minus 1/2 root 2 over 2 x minus pi over 2 to the 1 power plus, and let's put it down here, a negative 1/4 root 2 over 2 x minus pi over 2 squared over 2 factorial, and then plus 1/8 root 2 over 2 x minus pi over 2 cubed over 3 factorial.